The difficulties associated with risk management in cultural environment have been one of the main conservation concerns since 1980. Currently, the changes associated with the process of urbanization, as well as the effect of climatic change, pose new challenges for the conservation of heritage structures. In order to understand how all these factors influence the degradation of cultural heritage, in this slideshow, a methodological model is exposed and tested. By using the RRIS3 model and adding the use of satellite images, the level of water hazard can be identified in an urban historical context. For a better understanding, the slideshow is divided in two parts. Firstly, I'm presenting a brief definition of asset risk management and the proposed model. Secondly, I'm exposing the result of its applicability to the study of historic fortification in the city of Seville. Let's get started. The risk assessment is the analysis of damages caused by a possible emergency or risk event. The risk is a function of the threats that exist in a context, which can be evaluated estimating several statistical variables, such as precipitation average, highest temperature, and also the ability to respond to an emergency. This ability, called vulnerability, depends on different variables like materiality or state of conservation. In recent years, many research projects have emerged, making it possible to develop models and tools capable of evaluating the level of risk that affect the conservation of cultural heritage. Art Risk is a Spanish model that raises the following: identification of threats employing geographical information systems, analysis of vulnerability degree using vulnerability index and matrix, and evaluation of risk level applying artificial intelligence. Like other projects that have worked with hazards, one of the main difficulties has been how to develop a model that records the level of danger in changing environments. Just to give an example, how can we catalog the risk associated to rain in a context in which, due to climate change, it is expected that the intensity and frequency of precipitation will change? Or how to register the permeability of the soil in land in which the urbanization processes are active? For this reason, many researchers are looking for a model capable of identifying changes that can be updated quickly. Models based on the use of remote sensing offer a solution to the collection and updating on information on changes in the level of dangers. Remote sensing studies the element of the Earth's surface according to their emission spectrum. Hence, satellite images are actually a set of matrices that store the radiance values recorded by the sensor. Recently, the advances made in the field of remote sensing and the possibility of working on a big data scale with large volumes of satellite images allow us to analyze the changes that have occurred in the last 30 years from the use of statistical reducers and faction. The application to the analysis of a historical city allows a better understanding of the possibilities that remote sensing offers for heritage conservation. Seville, a city located in the south of Spain, has one of the largest historical centers in Europe, which, as in other Mediterranean cities, is delimited by an Islamic wall made of rammed earth. Not only because rammed earth presents a high vulnerability to water hazards, but also because climatic change is causing an increase in torrential rains on the Mediterranean coast. It is necessary to have tools to detect and solve possible risk situations. In order to identify water threats in Seville, the following output from the geographical information system of the R-risk tree has been collected: average precipitation, rain erosion, and flood risk, and also the information from the satellite Landsat and GPM. GPM is a constellation of meteorological satellites that collect information on rainfall. It has a temporal resolution of 1 hour and a spatial resolution of 10 kilometers. One of the main advantages of GPM is that the data collected by satellite is recalibrated according to the data from the ground stations. It offers high-quality data. Landsat has a much wider spatial resolution, 30 meters, and allows identifying anthropological changes such as urbanization, soil waterproofing, and the management of urban green areas. For the historical center of Seville, art risk indicate a low risk associated with average precipitation. And as we can see in the image to the right, there is also a low flood risk with return periods of 500 years. The erosive power of rain shows a high risk, and it is obtained at the ratio of the precipitation fallen in 1 hour and the precipitation fallen in 24 hours. This is an indicator of the presence of strong rain events that occurring in short periods of time. The use of function from the GPM images allow to comprehend the seasonality, frequency, and intensity of the precipitation that occur between 2020 and 2021. The x-axis of the graphs show the number of millimeters per hour fallen. The colored rectangles indicate the level of danger associated with the intensity of the rain. The most intense precipitation occurs in autumn, with maximums of 26 mm per hour. Summer, spring, and winter also register rain events, but with maximum of 12 mm per hour. It is also possible to generate maps employing the data collected with GPM software. The images show a statistical average of the day that presented the strongest rainfall event of 2020 in Seville. This type of information is very interesting to operate in largely broad context and identifying the areas that have been most affected by an event of torrential precipitation. On the other hand, the use of statistical reduction, band, combination, and normalized indices from Landsat images allow to obtain very interesting information. The NDVA allows researchers to identify urban green areas. As you can observe in the current slide, an average of the density of vegetation registered in the city in 1985 and an average of the density of vegetation registered in 2020 appears. The symbols in red correspond to the increase of the green areas in the city, indicative of its sustainable development. As we can see, these areas are associated with the riverbank areas and help to evacuate the water of torrential storms. Likewise, the build-up index, also derived from the historical Landsat, permit the classification by different colors of the urbanization processes of the city. Red correspond to those spaces that have been urbanized recently and that may be generating problems of permeability of the subsoil in which some of the structures are located. To conclude, the results obtained indicate that the erosive power of the rainfall due to the event of a strong storm
is the main danger that affects the structure in the city of Seville. The strongest storm recorded in 2020 occurred in autumn, lasted 6 hours, and had a maximum intensity of 25 millimeters per hour. The increase in urban green areas that minimize the effect of a strong storm is not hazardous for the conservation of any of the fortified structures, while the urbanization and waterproofing of the soil may pose a risk to some of the structures. The data obtained by the proposed methodology can be very useful for the specialists in charge of the maintenance of the structure, scheduling periodic revision, and the diagnosis of the damages caused by water threats.